Hey grade 8s, welcome back to term 2. I hope you had a good holiday even though you're in lockdown and you're ready to do lots of work for science in term 2. So when we last had a lesson, it was on why do heavy ships float, and I gave you these two videos to watch. I hope that you watched them, and part of your homework was to explain why heavy ships float. If you watched the videos, you would have learned that for a ship to float, the density of the ship must be less than the density of the water. And if you remember, the formula for density is mass divided by volume. So we've got mass divided by volume. So what I'm saying is that the mass of the ship divided by the volume of the ship, whatever answer I get for that, it must be less than the mass of the water that the ship displaces. So let's choose another color. If I fill in this ship with water, obviously it would actually be a little bit deeper within the water. So the volume of that water that the ship displaces and the mass of that water, that must be less than the volume of the ship and the mass of the ship. So mass of water and volume of water. Mass of the ship, volume of the ship. So if you do that calculation, if your value for the density of the ship is less than the density for the value of the water that's displaced by the ship, then your ship will float. If that's not the case, then your ship will sink. Please make sure that you filled in all of this information from the memo that is available on Teams. Okay, so we're going to look at today the temperature of a substance and how that affects density. So if you've got a substance that's a solid or a liquid and you heat it, the molecules are going to start to move faster and faster. And when those molecules move faster and faster, they actually get further apart. The substance still has the same mass. You haven't changed the mass. You haven't taken the particles out of the substance and you haven't added particles to the substance. So there's still the same number of particles. So the mass stays the same, but because the particles are moving faster and they're further apart, the substance will take up a larger volume. And if you've got a larger volume, the formula for density is mass divided by volume. So if your volume is increasing, you're taking your mass and you're dividing it by a bigger volume, a bigger number. So if you take the same mass and divide it by a bigger number, your answer for density will actually be smaller. And that's why your density decreases. So mass stays the constant. Let's just write that your mass will be constant. So that's constant, stays the same, but your density goes down. Your density is smaller. So if you take a number and you divide it by sorry guys, your volume is not going to be smaller, it's actually going to be bigger. Volume is going to be bigger. So if you heat it, the particles move further apart. If they move further apart, your volume is bigger. So if you take a number and you divide it by a bigger number, because your volume is increasing, then your density will actually go down. And that's why you've got decreased density. So your object is less dense. This can be shown pretty easily with liquids. If you've got hot water and you carefully place it on cold water, the hot water floats on the top because it's less dense than the cold water. When water is cooled, its molecules move more slowly. Its molecules move slower, and they get a bit closer together. So the water's still got the same mass because you haven't added or subtracted water or particles, so still the same mass, but it now takes up a smaller volume because the water is cooled. So when it's cooled, it's smaller volume, and a smaller volume results in increased density. So according to the formula again, density is mass per unit volume. Mass is constant. If mass is constant and you are cooling the water, then the volume will decrease. So your volume will decrease, and if you're taking a constant, dividing it by a smaller number, your density is actually going to go up. So there we go, density increases or density goes up. Okay, so if you've got cold water placed on hot water, the cold water sinks because it's more dense than the hot water. So there is a link to a video. The video is called Hot and Cold Water Density Experiment. So you can write that in there. See hot and cold in YouTube. It's spelled A and D, not with the and symbol. Hot and cold water density experiment, and I'm going to put that link onto Teams for you. That's going to be the second video that you're going to watch for today. And this is also why hot air rises. That's how hot air balloons work. Okay. Please make sure you write your name on every page of your density booklet. If you don't have a density booklet, if you're working from exam pad paper, that's fine. Then you're just going to write that you're working on page 15. So when you fill in these blanks over here, you're going to write density booklet page 15 so that you know which page you're working from. I'm going to ask you to photograph these pages, and the assignment that you've got on Teams will be to write your name on the top of each page, photograph the pages, use a camera scanning app. There are videos on how to do that on Teams, otherwise contact Saheti support if you don't know how. Scan it, paste it in a Word document if you need to, save the Word document as a PDF and upload that to Teams. Once you've done that, then I will respond with a mark for you, and I'll also give you the password to the memo so that you can mark your work yourself. All right, so effects of temperature on molecular motion. So if you have a look here, we've got a cold solid and a cold liquid. We've also got a hot solid and a hot liquid. Now look at the spaces between each molecule in the cold solid and also in between the cold liquid. Very small space between each particle. If you heat it, the particles vibrate more, the particles move more quickly, and they become further and further apart because they're moving faster. So notice how there's just like a few little lines around each particle to show that they're moving a little bit more slowly than when they're hot, and there's lots and lots of lines moving to show that the particles are moving a lot more quickly. Okay, so between each particle the space increases, and when you heat it, and as the space increases, that means that the particle takes up more space, its volume increases, the particle expands, the substance expands because the particles are moving more quickly within it. Okay, so a typical experiment for that is a brass ball and ring. When they're both at room temperature, what actually happens is that the ball can go through the ring easily. When you heat one of them, you change its volume. So say, for example, you take that brass ball and you heat it under a Bunsen burner flame. Okay, the particles inside that solid brass ball are going to go from taking up a certain volume, they're going to start moving more and more quickly, they move faster, they get further apart, so instead of it taking up a certain volume, it now takes up more volume. Look how the size of the red box on the left is smaller than the size of the red box on the right when the particles are moving faster because you've heated up the solid. So what actually happens is, instead of that brass ball being this size, you won't really see it with your naked eye, but you would if you were to measure it. It then takes up a little bit more volume. So the particles within that brass ball have expanded. So particles in the brass ball when it's at room temperature might be quite close together, whereas after you've heated it, it takes up more space, same amount of particles. I'm not going to count them all because ain't nobody got time for that, but if you count the particles, same amount of particles, so same mass, but it's got a bigger volume and therefore a different density. Now I'm sure you agree that you've heated it, that heated larger brass ball will not fit through the ring anymore. Okay. Other alternatives are to cool the brass ball, heat the ring, cool the ring, and I've got some really nice videos that explain all of this to you, and those are going to be the third and fourth videos for you to watch today. The one that actually put the ring on, or the ball in liquid nitrogen, which is really cool. By the way, this liquid experiment, you can try that at home if you have food coloring, and obviously you've got something to make hot water at home, and 2 glasses and a piece of cardboard. You can do this experiment at home. Please be careful if you are working with hot water. It doesn't have to be boiling, just heated water from the hot tap is suitable. Okay, so I'd like you to please watch these videos and make a little note on what you notice yourself. And then the next thing that you need to do is explain what happened. So you try and explain in your own words what happened. Do it in pencil, because once you've watched the videos and when I give you the memo, then I can give you the correct memo definition. So you just have to say something like that: the ball expanded on heating and it no longer fits through the ring if it was the ball that was heated in this experiment. Okay, explain what happened related to what's happening over here. So you're going to talk about how the particles in the ball, they gain energy from heat. They're going to vibrate more. Because they vibrate more, the solid or the ball takes up more space and expands. And if it expands, then it won't fit through the ring. And remember, if the mass stays constant, as I explained to you before, the mass stays constant because the number of particles in the ball remains constant. If mass stays constant, but the size of the volume changes, then the density will also change. Okay, so please, like I said, do that in pencil. And your homework for the rest of this week is to complete this booklet. Once you've done that, you're going to take photos of it. Like I said, remember, please put your name on every page, name and surname, and your grade. And then you're going to photograph it, put it into one single PDF document, upload it to the assignments tab on Teams. So you go to Teams. In grade 8 science, there's an assignment. So this is the assignment density booklet, evidence of completion. So there are instructions there. Please can you make sure that you do this by Monday the 4th of May at 3 o'clock. So there are 5 points. You're going to get a point for doing it on time, and following the instructions is how we're going to mark it. Once you've done that, then I'll reply with a password so that you can open up the memo for the density booklet that is on Teams. Okay, please also make sure that you have read all these instructions from Dr. Thornton put up yesterday. And if you need to get any IT help, there is a Saheti team. These are the links for the videos on why boats float from last term. If you haven't already watched them, please make sure that you do. And if you need any help on how to use the Office Lens app, this is point number 5 over here. Please watch the following video from Mr. Haynes. There's a link to it, and that explains how to take a video and save it as a PDF. How to photograph your work, either your booklet or your exam pad paper, and save it as a PDF. Also, if you've got an iPhone, there's another alternative that you can use too. There's the video link to that. So that was taken on 1st of April. Okay, so your homework today is to please make sure that you have watched the hot and cold water density experiment and then the 2 videos on the brass ball experiment. Thanks, Gr8s.